Hello everyone, welcome back to Math with Sanger. Let's continue on FRQ question 4, where no calculator is allowed. You can pause the video and go over the question. Part A, find g0 and g4. Since gx is the integral of f from -4 to x, so we're accumulating the sign area. Let's find g0. Basically, it's area from -4 to 0 of graph of f. So we are finding the area of a triangle and the parabola. The question given that the region A, which the parabola, is 3. But remember, the parabola is under 0, so it's a negative area. The triangle has a base of 3, -1 to -4, and with a height of 3. So g0 is equal to 3 times 3 times 1 over 2 minus 3 equal to 3 over 2. That's g0, and let's find g4. g4 is the area from -4 to 4 of graph of f. And we have found f0 already, so we only have to find the area from 0 to 4. Area from 0 to 1 is also given. Region B equal to 5. So what we are only looking for is the area from 1 to 4. The question given that fx is equal to this function when 1 to 4. Integrate term by term, and that gives us this integration is equal to 9 over 2. Both of the region from 0 to 4 are above the horizontal line, so we just add up everything. 3 over 2 plus 5 plus 9 over 2 equal to 11. So g0 is equal to 3 over 2, and g4 is equal to 11. And that's question A. Question B. Find the absolute minimum value of g on the closed interval -4 to 4. Justify your answer. For an absolute minimum on a closed interval, we check first endpoints, second critical points. Question given that g prime x equal to fx. Critical appears when g prime x equal to 0, so we want to find fx equal to 0. Now let's take a look at the graph. Two endpoints, -4 and 4. And the critical points when f is equal to 0. That's -1, 0, and 1. So we want to find g -4, g -1, g0, g1, and g4. To see which one is the minimum, we have already found that g is equal to 3 over 2 and g4 is equal to 11. We also know g is the sign area under graph of f. So g -4 did not move at all with no area, so it is equal to 0. And -1, which is the area of this triangle, which you also calculated, is 9 over 2. And g1 equal to g0 plus b, which is 5, equal to 13 over 2. So with these values, we notice that the smallest is 0. So the absolute minimum value of g is -4, which is when x is equal to -4. Question C. Find all intervals on which the graph of g is concave down. Give a reason for your answer. So we notice that g prime x is equal to fx. So g double prime x is equal to f prime x. We want to find concave down, where g prime prime x must smaller than 0, which means fx has to smaller than 0, which is when f is decreasing. So let's take a look at the graph. From negative to -1, this line segment is going up, and this is going down, which is decreasing. So it's from -2 to -1. This parabola, since the question given that the graph has horizontal tangent 1 over 2, so it decreases from -1 to -1 over 2, and then increases from -1 over 2 to 0. So we can change this to -2 to -1 over 2. Same for this parabola, have a tangent at 1 over 2, so this is increasing and this is decreasing. So we have 1 over 2 to 1, And let's take a look. This parabola with the function of negative f squared plus 5x minus 4. And then we want f prime x is smaller than 0. So negative 2x plus 5 smaller than 0, x bigger than 5 over 2. Where we can also visualize that is decreasing. But we need the coordinates of the interval, so you still have to derive it. Okay, from the given explanation, the g is concave down on negative 2 to negative 1 over 2, and 1 over 2, 1, and 5 over 2, 4. That is when g is concave down. And that is for question 4.